So Telco Edge platform, secure, scalable, sustainable MEC. So Dave, if you don't have to worry about watching the chat box or anything, we'll keep an eye on that. So you concentrate on your presentation, and if questions come in, we'll interrupt you at an appropriate time, if that's okay.
Fantastic. Graham, thanks for the setup. And if it's okay by you, I'll take it away.
Absolutely.
Great, thanks. Well, welcome everyone. We're glad to be happy to be back on IWBC. This has become a regular thing for us, especially around this time frame. Every springtime with the IWBC. So we're happy to be with you, and we have another installment of our Intel 5G RAN testbed, which is pretty exciting. Since we last left you, I think it was stage 2 of our testbed. Actually, maybe even stage 1 of our testbed, actually, last spring, yeah. So this has been going on for a year. My understanding is it might be the longest running Intel testbed that they've had. We've went on to win a whole bunch of awards. This stage 4 is exciting in particular because the previous 3 installments were all private MEC, and in this testbed, in this demo today, we extended it to a public MEC scenario with the secure edge gateway. So we're glad to welcome AWS to the team, and you can see, of course, got a sort of all-star team of partners here with Fortinet, AWS, Tech Mahindra, Intel, obviously, Keysight, Tech Mahindra, and KX. And it's just sort of blocking my slide there. So, this whole series of demos, it started working with Intel, and it was all about programmable networking. Intel is promoting its open APIs, its interfaces, P4 interfaces, over its network infrastructure, hardware, and software. And EnterpriseWeb, as an intent-based orchestrator, is leveraging those, right? We're raising a high-level abstraction over the top of the network, across the RAN core and transport, as you'll see in the demonstration, to continuously optimize the processing of secure packets. And we're going to actually share some early test data with you as well, as we have in previous demos. As Graham noted, the slides will be available and there'll be a replay. So some of these slides we'll move through pretty quickly because we want to get you to the demo. But don't worry, you'll have the deck will be made available to you. The demo will have a replay. So you don't have to worry about screenshots or trying to, taking notes or anything on any of the individual slides. So really good news here, and the whole point of this demo is to really show enablement of public and private MEC, right? Consistent, predictable, low latency and energy consumption at scale is really key to the success of these initiatives, both to MEC itself, right, from a profitability perspective, but also from a sustainability perspective. Right, we have to work within the constraints of the edge, right? And so we have to do more with less, because we're going to have less compute, less energy resource, et cetera, and we're going to have to work within those confines. And so optimizations are sort of critical to the enablement of that. In this demo, you're going to see a variety of sort of key telco concepts being met, and we're going to touch on them to varying degrees. But just to summarize here on this slide, you're going to see some AI ML ops in the sense that EnterpriseWeb, in this test bed, we have a partner, KX, and KX has a vector-based time series analytics database that we work with. It's kx.com. You should definitely check them out. And we essentially are programming them, right, with a model, with rules, and with triggers, so that essentially we're pushing AI ML workloads through KX. So we're leveraging that database for AI ML workloads, and it's a low latency, ultra high performance database. So that helps us with the closed loop assurance. So that's they are part of the service-based SON you see on the right side there, the blue box, the hexagon. So when we program them, we're able to flexibly point them at all the relevant vectors for real-time, near real-time, self-scaling, healing, and optimizing. So unlike traditional SON, right, heavyweight, loaded, vendor-centric, batch, here we're talking about something that we've programmed that we can point at any of the relevant vectors for the service. So IPMI, the interfaces over, the IPDK, as well as interfaces, service, the functions, the slices, etc. So we're actually able to do sort of a co-optimization across the set of vectors, which is very powerful, and you'll see that in the demo. Digital twins, well, that's because we're modeling all the participating elements as software objects with state and behavior that are under active management. So we're essentially getting this active assurance going across the set. All those elements get declaratively composed into an intent-based service with closed-loop control. And again, you'll see all of these elements as aspects of the demo. Programmable networking I already touched on. And lastly, I'll point out the sort of adaptive 5G security, which is sort of an exciting aspect with Fortinet, because Fortinet itself, its FortiGate products already have an AI element to them, where they're reacting to changes in the environment, changes in the traffic. In addition to that, EnterpriseWeb is configuring them at the application layer. So there's really almost 2 layers of adaptivity. It's the sort of inherent adaptivity built into their Fortinet products, but it's also EnterpriseWeb looking at the volatile network itself and constantly reconfiguring the elements for a volatile network. Collectively, we're delivering on autonomous network. Some of you have been following this test bed. So like I mentioned, it's been a year, and you can actually see the reference. It was, I guess, June 29th last year when we did the stage 1 demo with all of you. At that time, it was just the first demo. It was within, I think we achieved it within 3 to 4 weeks of this consortium coming together. And we were demonstrating just 1 gigabyte per second for the private MEC, or secure 5G gateway. Then we went to 10 gigabytes per second in the fall, and then we went to 50 gigabytes per second. Now we're sort of stepping to the side a little bit because we're now going public MEC. So we're constrained by the nature of distributed systems. We're working through VPC, but we're super pleased to have AWS on board. We're putting the 5G core properly into the cloud, and we have a cluster of edge nodes running in Intel Labs with Red Hat's advanced cluster management present. So this is becoming now, sort of extending beyond the lab to become more of a real-world scenario. We recently presented, just last week, presented aspects of this demonstration at the ONF P4 workshop, which was very exciting. Nick McEwen was there from Intel. Larry Peterson was there. So some of the thought leaders in programmable networking were there, and we got a lot of encouragement or sort of high-level layer 7 abstractions driving programmable networking. But today, you're the first people to see the full demo. So here's a new testbed service topology that sort of properly shows the edge sites, the core site, and the management control plane. So again, it's a 5G RAN network with a secure edge gateway. If we start with the core, you're going to say we're going to be running with AWS and EKS over here. And you can see that for the core, we're running with ONF's Aether project, so that's their SD core. We got their SD-WAN over at the edge. We got FortiWeb at the core. We got FortiGate at the core, providing the secure gateway, also enabling the SD-WAN. We're doing web conferencing as the business app, so that you can actually see the impact of traffic and attacks on jitter and the availability of that video. SLAs and FLOSS. And we've got SciPerf there for the emulated applications and attacks. On the edge, we got 3, courtesy Intel, we actually have 3 edge nodes running CoreOS and OpenShift. As I mentioned, we got SD-WAN out on the edge. We have FortiWeb on the web, providing the web application firewall. We also have FlexRAN deployed for layer 1. Dynamically configuring that as well as open source Prometheus and Grafana that's supporting some of the observability that we're doing for the service-based SOM with KX. So speaking of sort of management controls or observation, sort of at the higher level, we've got KX observing both sites, providing the SON signaling to EnterpriseWeb's Cloud NFV. Cloud NFV is our telco-centric solution. It has a harmonized model of the telco domain. It includes 3GPP standards. It includes models of ORAN standards, TMF open APIs, ETSI standards, MEF standards, etc. in a one harmonized graph model. You see that as well. And Keysight SciPerf is present here as well, here at the management control plane, acting as controller. So everyone is well represented, and all the partners are well represented in this demo, in the use case, and in the sort of enablement layer. We're going to do a couple of different scenarios. First, we're going to just be simulating traffic. Again, this is truly a distributed scenario. You're going to see it's a live demo that we do. And so it's, at this point, we have to drop back down to 20 gigabytes per second for working through VPC. SciPerf is, simulating a realistic mix of traffic, web, storage, email, file sharing, video, etc. For another scenario, we're going to have SciPerf emulate some attacks for us. So we're going to essentially insert some bad actors, see the impact of that and how fast the SON reacts in a closed loop with EnterpriseWeb. So KX, you're going to see essentially from the time that KX observes it, throws an event to EnterpriseWeb, and the mediation takes place, and we get the ACK back from the network. We're doing that within somewhere between 300 and 400 microseconds. So, really impressive performance data. Again, we'll be sharing some of that performance data with you today. We're adding a new scenario, sort of a scenario here, which is we're going to make this a realistic edge demonstration. I'm thinking about how the telecoms have to work as you exponentially increase the number of sites that are going to be deployed in the real world, and they're going to be exposed to weather conditions, disasters, man-made and weather-based, as well as cyber attacks. So, it's going to be a normal course of work of operations that nodes are going to be going down for whatever reason. And that's going to reinforce the need for near real-time, autonomic closed-loop, self-scaling, self-healing, self-optimizing, right? And so you'll see how quick we react and rebalance when a node goes out. So showing you some of this data, and I really want to point out, you probably can see that there's a draft watermark underneath this. We're calling this initial stage 4. We have great players on this team. It's not only just Intel, but also Keysight. And so we're leaning on them, obviously, in their testing expertise. And we haven't had the fullness of time to do all the testing that all the parties would like. So we're confident this data is good. It reflects the fact that this is now a distributed scenario. So latency has gone up with the distribution. We believe these numbers to be quite accurate, but we're not reporting them as final numbers until we've fully validated them and all the partners are find them acceptable. So draft numbers, so take them with a grain of salt, but we've been doing this now for a year, and these things have been bearing out. So you can see that we're doing 20 gigabytes per second with and without the SON, and then with the SON. We can't really do A/B comparisons with stage 1, 2, and 3 because this is now a public MEC scenario, and some of the configuration is quite different, so it wouldn't really be relevant. So what we're really just doing is an A/B without the SON and with the SON. And what you're going to see is that without the SON, with the SON, we're getting a 24% plus reduction in latency. We're getting a 29 plus reduction in latency under attack. We're consistently maintaining security at a high level. It doesn't change. And then we're getting some pretty impressive numbers here in energy consumption, resource efficiency, et cetera, right? 8% improvement in energy consumption, 9.1 times more energy efficient when you look at it per gigabytes per second throughput. We're also putting up some impressive numbers on resource efficiency, both CPU and RAM. Again, this deck will be made available. We've also committed to Graham and Tom and IWPC that when the final numbers come out, which we hope to do in the next week, we will share that in an updated deck so IWPC can share that with the community. We have a full commitment to Intel and all of the partners that we were completely transparent in the data from this testbed. So enhanced SON is improving latency even under attack while maintaining security and quality. We're optimizing energy consumption and physical resource consumption. I think all of those things are obviously important to the telcos on this call. So with that, I have one more slide to show. Now some of you have seen this slide throughout the previous instances of this testbed. And what you're going to see is actually we're maintaining this in a distributed environment. So yes, latency has gone up. So what you can see here is these different dotted lines. So you can see the blue line is just the service without the SON, right? So as we scale it up to 20 gigabytes per second. The red line is without the SON and we're under attack. So you can see latency increases as you would expect as we increase throughput and traffic. Same thing with the attack. But when we activate the SON, you can see then correspondingly, without attack, we have a near flat line. With attack, we still maintain a near flat line. Yes, it is, of course, a bit incrementally more latency than when we were just running this in the Intel lab. But I think you'll find it still impressive data. Now, when we go to energy consumption, power consumption, it actually stays almost perfectly consistent with the private MEC inside Intel's lab. So almost a flat line. So while we see the traffic is going up to 20 gigabytes per second, we're seeing the attacks and the traffic together. You can see once we activate the SON, it just comes right back down. And you will see that the reaction time is near instantaneous. When we're talking about working at the speed on mitigations at the hundreds of microseconds, I think it's fair to say that that's near real time, almost near real time. I'll leave that to the arbiters of those standards, but certainly damn good. As far as another interesting aspect of this testbed scenario is collectively the solution is consuming very little resource relative to the use case, right? So when we look at this, the use case is taking up about 95% of the consumed memory CPU power. And you can see overall, so that's Keysight, that's KX, that's EnterpriseWeb, that's Rackham. The enablement layer is as discrete from the use case, is consuming very little, right? So very lean solution. That's going to be another very important aspect to your edge initiatives and your sustainability initiatives. So with that, I'm going to pass it to Bill. Bill's going to then, I guess, Bill, I'll probably pass your slides for you. I'll probably push the slides for you unless you can take control of it.
Well, I can push them on my side, or you just go ahead. I'll talk over. All right.
Great. Hey, Bill, just hang on a second, just in case anybody has any questions. Let's just see if anybody has anything they want to ask at this point. If not, then please just go straight ahead. I'll just keep an eye on the chat, but I think what we'll let you do is just carry on, Bill, if you won't mind.
No problem at all.
Great.
Thumbs up. If you see a question and it looks timely to what we're on, Graham, feel free to interject, and we'll pause and answer the question. Otherwise, we're certainly going to stay on the line for Q&A at the end.
Yeah, perfect. Perfect. Thanks, Dave. Okay, Bill, all yours.
All right, thanks, guys. Great to be talking to you. As mentioned, I'm Bill Malik, Chief System Architect with EnterpriseWeb. So I'm going to pick up where Dave left off, and I'm going to do a bit of a deeper dive on some of the technical aspects, and then I'm going to carry on to the actual demo itself. So you get to see this thing, a nice snapshot of what we've done in the testbed. So just right now, we're looking at a bit of the deployment, or really the distribution of that public MEC scenario. So as David mentioned, we have the 3 edge sites that you can see over on the left there. They're all deployed into the Intel Test Lab. Each one is just a small cluster, and all of them were deployed using Red Hat ACM. Right, so each one of these nodes was instantiated using this sort of management from the core. So the idea being that you have a kind of, almost a zero-touch, instantiation of each one of these edge sites, in addition to, of course, all the services and everything else that you're going to actually run through them. So that's the deployment of functions and so on. You can see them all kind of listed here. within the slide, and you can always go back to it. But the main distinction is that most of our management stuff is in the core. So that's the AWS site that you see on the right, deployed over EKS. It's a nice example of how we go across, a heterogeneous environment in a very true sense. And of course, they're all connected through VPC. So that's from a high level. Now we're going to drive into a lower level detail of that. So Dave, can you go to the next slide, please? So this is the solution architecture, and this is really almost exploding the detail and of course revealing things like the interfaces and a lot more of the kind of physical deployment of the services that you saw in the earlier diagram by Dave, where he's showing the service topology. So in the solution architecture, you can see there's the 3 edge sites on the Intel lab over on the left. And as we talked about before, we have the RAN components distributed there and some Fortinet for protecting any sort of local or edge applications. And then in the core itself, we have the rest of the sort of applications deployed. What you'll notice though, so just a couple of things here, and of course you can go into all the details later, but EnterpriseWeb here is actually playing a number of roles. You'll see it. They're all discrete deployments of EnterpriseWeb. There's an SMO in the edge. There's an end-to-end orchestrator and other slicing components that are all in the core. Now, what this allows us to do, which is actually pretty interesting. So first, we have a very small footprint, 50 meg deployment, efficient. That's what you really need for edge and core. That's one thing. But what we're doing here is actually being able to sort of give an end-to-end that you really don't see other places. We have one model. So within EnterpriseWeb, we have a common technology that lets us actually reason across the 3 domains that you see here, the RAN, the transport, and the core, and then top to bottom. We'll describe it in another slide coming up, but we actually are able to take things at the high level of intent. And you're going to see in the demo, I'm not going to describe things at a low level. I'm not going to talk about connecting an R1 interface to a particular component or anything like that. We talk about things at a high level, that we need an SMO to manage the RAN itself, what the RAN component will be, things like that. And that intent is going to be translated right down to the sort of NFV layer, which is the network functions and everything else, and then right down to the SDN layer as well. So layer 7 down to 1. By having that kind of top to bottom and end-to-end solution, we can actually reason across this whole application that you see here. We can take application state and configure a partner like KX, for instance, who's going to observe this entire state and that kind of end-to-end, and then throw events to us that actually cover the spectrum. So we have something that's not just an SMO that's kind of your typical, locked into just the RAN. We have this enhanced SMO that really covers the full spectrum of what you need. So application state can be taken from everywhere. You can fuel your SON, you can make adjustments and continuous optimizations that aren't just limited to a specific domain or a specific component or a specific type of telemetry. So you can of course go back to this slide more, but just touching on a few of the the more interesting. There was a question. I'll just take it right now. So you can move things pretty. You have a lot of flexibility in how you want to model the intent for these. So we just went with our deployment of putting the UPF in the core. We can certainly move it to edge sites, and really those kinds of things become they become sort of preferences for the, I guess it would be the actual service designer as far as where they want placement. And you'll see that there's policies everywhere for placement, and it's sort of up to your choice. We chose the core for this case.
And they'll see it in the demo.
Yeah, so exactly.
You'll see how SLA, because everything's fully declarative in EnterpriseWeb. You're just composing the objects, and then using policies, the service chain, and as well as SLAs and SLOs to specify that intent over the network, and that's both done at the individual element level, as well as collectively policies over the set of elements. Allowing that configuration at all levels. And even though it's declarative and no code, everything is, you can drill down into any level of detail at any time. So, and Bill's going to show you some of that as well. You'll see transaction traces. You'll see how everything's graph connected. So Bill just giving you an idea. We have about 15 to 20 minutes left for everything.
Okay. So I'll take a little bit less time on these next few slides. I just want to touch on a few of the key aspects here, and you can, obviously drill into more detail offline if you want to. But some of the things that we're doing that are really interesting with security here. Fortinet itself provides obviously a FortiGate product, which is very well known and massively distributed, but a lot of people in most applications just really statically configure it. And what we're doing is, you're going to see in the demo, we have models of all the participating elements that are in this solution. So we're able to actually dynamically configure FortiGate and even apply the sort of concepts of adaptive security, that when application state changes, so when we're under attack, for instance, or other things, you can see it sort of listed on the right hand side. When Cypress starts the simulation in our demo, what we're able to do is detect that things changed in the network, that we need to prioritize network, for instance, traffic to FortiGate in an attack scenario, and things like that can actually be adjusted through our SON. In addition, we're also leveraging the fact that we can use FortiGate to do things that people aren't typically doing, like secure the control plane. So we're doing a very advanced implementation of FortiGate in this kind of a case. And again, it's zero touch throughout. So we're doing a dynamic configuration of this without someone having to manually learn FortiGate. That's one of the advantages of what we're doing here within the testbed and the modeling. And then, going further into FortiGate itself, we're also able to leverage that AI that they actually provide. In this kind of a case, the FortiWeb component that we added to in the last stage, so in stage 3, we're actually able to do the kind of adaptive app-specific security, so that as threats kind of emerge, the system is actually learning and able to sort of run AI at 2 levels: the SON itself, optimizing all the services and everything else, and then kind of an inner loop, which is actually detecting new threats and able to sort of patch things dynamically on the fly. Continue on. And then just a bit of a sort of note on what we're doing with P4. As I mentioned a little bit earlier, one of the interesting things in this testbed is that we have a high-level abstraction that actually drills right down to the lowest levels, right? In this kind of a case, we're aware of, on the bottom, you can see the E810 Ethernet controller. So that's the Intel chip that actually has a P4 interface, so we can program it. So when we talk about things like the SON, right, what we're actually saying is that at the highest level here, we have that intent-based service. We, of course, figure out what our service chain is going to be. But then what we're doing is we have this continuous closed loop where we're taking signals from the various state, so both telemetry, the actual element, the solution elements that are involved in the service, any performance monitoring that might be there. And what we're able to do is, actually prioritize traffic. So we use IPDK stack, which basically says, okay, take what they call an application device queue, prioritize traffic to a specific application, push that down to P4, push it into the chip, and continuously readjust this to make sure that we're optimizing our traffic. And that's what really leads to things like the power reductions and basically the improved performance as well. So as far as the demo itself, I'm going to go through a fair number of the more interesting parts of it, but even though it's zero touch, it is going to take more than the 10 minutes or 15 minutes we have left. So in advance, just letting you know what we've done, we actually set up that K8s cluster in AWS. Using EKS, we installed an instance of RHEL along with Red Hat Advanced Cluster Management. We then use that advanced cluster management to stand up these edge sites. You'll see that in a minute. And then we deployed all of our operators, all of the management components, and we modeled all of the solution elements in advance. So day 0, I'll talk about in a moment when we get into the demo itself. And then as far as the design time modeling, what you're going to see is I'm just going to do a high level. Basically, I'm going to show you the service that we modeled. I'm then going to actually show you what the system developed in terms of a deployment workflow, and then we'll concentrate on day 1 and day 2. If you can flip to the next slide. So this is the deployment workflow that the system puts together based on my high-level intent. There's a lot of detail here you can go through, but basically in any of these deployments, you have this sort of same kind of 3-stage deployment: establish infrastructure, instantiate the services, and then configure the services. All the detail here, though, is going to be driven, and you can see it's low-level detail, what interfaces to use, what kind of orders to produce, all the configuration. All this is zero touch, and it's pretty diverse. All those details are going to be figured out by the system based on basically those high-level policies and declarations that I make.
Here is that everything is executed in parallel, that can be executed in parallel, and then when you reach a logical step, essentially the system's transactional, right? So everything that happens in one stage has to happen. If anything doesn't happen, the system will, allow for retries and all of those things like that. If it can't connect to something, then it'll do compensations, etc. Because the service has to succeed or fail collectively. It cannot partially succeed. So we manage that at every stage. So, we do everything in parallel that can be done in parallel. Attempt to, do a closure over each stage. And then once a stage completes successfully, we move on to the next one, again, then massively parallel, and then we go back. And that kind of ability to do sequential and parallel allows for both the logic of the logic of the flow of deployment, but also allows for efficiency, parallelism. And then, of course, the security and control of the transactional guarantees.
So just before I jump into the demo itself, just a bit of a zoom in on those closed loops that we talked about with the SON. You can see here there's a RAN optimization going on. So it's a closed loop between us, our SMO component, and the real-time RIC, et cetera, to actually reconfigure dynamically that RAN access. And Dave, if you can go to the next slide. We have something similar going on at the core as well. In all of these cases, what we have is KX actually observing a number of vectors, as Dave had mentioned earlier, across the services, slices, network functions, infrastructure, et cetera, taking that detail and then throwing events to EnterpriseWeb when it needs to make changes in the services themselves, so we can have a continuously optimized system. And there isn't, as we mentioned at the beginning, there isn't really a sort of divide. There isn't a explicit closed loop for either. We're showing it at two different scales here, but really this is a holistic measure. It's taking, just in the same way that it's going to take intent about the service and its elements, it's really optimizing the service as a whole. So you're going to see that within the demo itself. So with that, I'm going to take control.
I'm going to stop sharing, Bill, and let me know.
Yep, give me a second.
Okay. Do you want?
All right.
While you're just doing that, guys, we did have one question came in. I think it was just a clarification, and it came in from Johannes Scheidt. Wouldn't it be more logical to put the UPF in the edge site? I imagine there would be local internet applications that connect to the UPF. Could you just talk a little bit about that, Dave, or?
I think we covered that as we were actually in progress.
Yep.
We had talked about the fact that that's actually a decision that you can make as part of the service when you model it. And yeah, there are many different scenarios that we can support with this deployment.
Okay. Hey, well done. Thanks.
No problem.
Flexibility and choice, right? Because any telecom use case could be deployed multiple different ways, and so part of that actually becomes a strategy question. And since EnterpriseWeb is 100% configured by metadata, right? We leave those policies and arrangements to the customers. We're not opinionated in that regard. We want to preserve all flexibility and agility for the telecom customer.
Great, thanks, Dave.
Exactly. All right, so first I'm just going to start a quick orientation. So we have an environment here. We have the 3 edges and the core site set up in AWS. And you can see my target environment. It's empty right now on the edge for actually deploying it'll be the edge components for actually delivering this. So we can just see it in real time. Makes for a nice demo, and it's pretty concrete that way. I'll then be spending a lot of my time in the EnterpriseWeb components. So just a very quick orientation. EnterpriseWeb itself is a set of distributed pods, all cloud native, small footprint, 50 megs. The actual modules themselves are just divided along your typical telecom roles. So I'll just tell you what role I'm playing and which module I'm using, but they're divided up into things like an application manager for onboarding XNFs, a service manager for composing services, a model manager for an architect to manage their models, etc. I won't go into the detail here, but I'll let you know what role I'm playing and what I'm doing. So right now I'm actually looking at an instance of the application manager. So it's been deployed and security on every click. So what I'm looking at is a catalog of all the components that have already been onboarded or will be used to create the actual service that I want as a service designer. So I'll pick out of this catalog. We don't have time to get into day zero, but there's a lot of interesting things about this catalog. I'll take a minute or two just to expound on a couple of them. First, of course, we can find all of the partner components that we'd expect within this catalog. All the things that you're going to see within this demo, they all have a model. What's important is that every one of these objects within EnterpriseWeb is actually modeled in a sort of similar way. They have common metadata that allows us to apply common methods across them. They're all immutable objects of a type, which will drive what kind of data collection. We make that really easy. People can either use an API or in a lot of cases, just do things like upload a YAML file or their package. If they have that, a tar, let's just say, that's given to them by a vendor, the system will take it apart, introspect it, and match it to models and sort of drive, if you want, a sort of fully executable model. So I'm going to show you one of these, right? And we could go into any one of them. The Aether stack itself happens to be one of the more interesting ones. So let's go ahead and drill into it. Now, every object in EnterpriseWeb, because of that sort of common metadata, is wrapped in a case. So you get all of the sort of management capabilities that you'd really want. You get this kind of concept of an access log, security, versioning, etc. So everything in EnterpriseWeb you can roll back if you need to. It's all safe, all that kind of good stuff. As far as the actual model that's been built up for one of these, it of course includes all the deployment parameters, the kind of things that you used to get from an Etsy, for instance. So definitions of actual deployment units, so the components, for instance, you can see a lot of them here, and you have flexibility in how you want to model these. That's all good. Beyond that, though, what we're doing is actually capturing things even at a higher level. So we have things like application behaviors within our models in EnterpriseWeb. In this case, you can see some of the component models and app models that you'd probably be familiar with. These allow us a sort of higher level understanding of this component. I onboard an Aether stack. The system can then do things that are a lot more than just deploy. And of course, this is all mapping up to a model. So I'll just show you that really quickly here. There's a graph being generated behind the scenes, which the system is going to connect dynamically. So when I add this to my network service, it's aware of things like the DUs, the actual life cycles, management operations that are available, things like being able to use Helm versus whatever, right down to even things like what kinds of standards and interfaces and so on we might want to connect. The point is, though, we have this connected model that then lets the system do that kind of zero-touch deployment on its own and infer a lot of things about how this thing might be optimized. We can go into a lot more detail in other demos, but that gives you a good idea of sort of the catalog that someone is using as they implement one of these services. So I'm switching gears now. I'm going to play the role of that service designer, and then we're going to start to look at sort of what was already modeled for this demo. And then we're going to actually, execute the function. So you can see my catalog, slightly different. I'm a service designer, so I need to know about things like host clouds and so on, where I might be deploying my service to. Same kind of concept, though. When I come into my network service, it's wrapped in a case, all that kind of stuff. This is really just a composition. I can go in and I can actually look at, well, what instances have been deployed, right? So we already have 2 edge sites stood up. We're going to add a 3rd one here as part of the demo, right? And of course, there's things like VDUs that are already stood up. The web conferencing service is already in the core, right? But let's look at the model that was done, right? And so if we look at the model, all that someone does when they're actually composing the service, they're leveraging all that good work that has models of the components you saw and then the technologies below, things like P4 and so on. What they do is they pick out of a catalog. You can see a number of the components here. I won't go into the details, but they're all the things that you saw in those slides before. They compose it into a network service chain, and then really from there, I mean, they're given out of the box a sort of minimum viable deployment. They can go in at any time and describe something that would be a lower level intent, so a service level intent, like service chaining, for instance, that might be applied to the whole thing. Apply custom models, and it goes to whatever level of depth you might want here. And then they can also apply intent onto the actual elements themselves. And this will all be taken holistically. So it's not just going to optimize an element in isolation. It's going to take this all as one sort of one set of directives that are really going to power our SON optimizations and power our deployments, which I'll show you in a second. Here, just mentioned earlier, we're securing the control plane, a benefit of having the FortiGate on board. And then at a high level, we're describing what the intent is, which is really going to drive the SON, right? What kinds of things we want to be able to optimize. And they all come out of those models you saw earlier. And then it comes into some things like, if I want to, I can go down to actually specifying some things in terms of even the SDN level qualities. And again, I'm not going down to programming or anything like that, but I get this nice high level intent. And it lets the system do two things, right? One is generate actual deployment plans, right? So based on that plan, you can see earlier in that slide, we had that single deployment workflow. Well, here you see a variant of it that really is very focused on what we actually want to do, right? The specifics of instantiating firewalls and whatever. And you can always drill into the details of these things. And this is, just to be clear, this is just a state chart representation of that workflow. Stages kind of go linearly. Other than that, you have tasks that sort of naturally arrange in them. And the flows between these are all logic based. So there's no specific workflow. It's not like a BPMN chart or anything like that. This just makes it easier to represent. And this workflow is what we're going to actually deploy just in seconds here. So that's what the system will work through as it actually creates a new instance. So I'm going to pause here. I'm going to actually shift over now and do the day one and then day two of this. So I'm going to deploy a new instance. So just for purposes of demo, I'm going to deploy it without the SON policies in place, right? Otherwise, what will happen is when we turn on the simulations, you won't really see anything. All you'll see is lifecycle events. You won't get the full feel. So I'm going to go ahead and actually deploy that. And I'm just using, we have all standards-based interfaces, MEF, TMF, etc. In this case, I just created a very simple one for our demo itself. So I'm going to go ahead and actually deploy that, right? So systems deploying, great. And you can see, okay, the background, we've already got a deployment element being created here. If we jump into OpenShift, we'll see, okay, the deployment's actually coming in as soon as that thing catches up. And then this will come live within, it's a few seconds before you're actually able to, yeah, there you go. So we've got our system up on this, or so I guess our service up on this new edge. We can drive into it. We can see some configuration detail. We can see the life cycle of it. And what we get is this sort of trace that goes into a few hundred high-level elements, and it covers everything from fetching a deployment plan, touching ACM, resolving environments. Eventually, it'll generate, install FlexRAN policies, configure subnets, VDUs, etc. It goes into the full depth. And as David mentioned, it's a full transaction. So if anything failed, it would capture the rollbacks and whatever. But this is going to be a full kind of audit and trace capability now for any event that goes on in the service. So I could look at the VDUs, and of course it's a mix of what's in the core and what's on that edge as far as that particular edge site. But now what I want to do is actually use the service, right? So I'm going to do that. Here I'm going to actually place a small call here over the service. Just a second here. Okay, so just a moment. I'll have to mute some things. And just a second. Okay, so now what I'm going to do is I'm going to place a video call, right? So you're going to see from, one device to another, this is me, right? So what we're going to do now is we're actually going to activate, so two things here. I got to show you a couple of things. So we've got obviously our little demo APIs. So I'm going to start traffic in a second. The other thing to note though is we talked about KX, right? So let me get a little KX a dashboard up here. Okay, so let's get all these up on the screen quickly here. Okay, so what's going to happen now is that I'm going to activate the actual start the traffic, right? So what you're going to see is a couple of things. Remember, the SON's not in place, right? So as I do that, right? Okay, so the traffic's already started. It'll give me a report here in a second, but you can see a couple of things. So I no longer have the bandwidth to actually do the video itself. And then I have these kind of spans here that it's trying to get back into, right? So you can see it's actually juggling. You can see these signals that are being sent over to EnterpriseWeb, right? But they're not being fielded because there's no SON actually in place right now. There's no SON policies. So events are being thrown, they're not being actually resolved. So let's go ahead and activate those policies, right? So let's go ahead and do one. And then let's get the second one going, right? And then as soon as they start to kick in, okay, so our video's back, which is great, right? And we've got this, you can see our SON levels are all dropping down back to where they should be, which is good. If we go into EnterpriseWeb back in here and we look at the lifecycle now, you'll see that there's a number of those policies, and they're all kinds of things from SON, direct SON adjustments, scale outs, heals, whatever it needed to do to actually be able to restore that service is what kicked in, right? So that's already pretty dramatic, and that's where a lot of, because this is going on, you can see it's continually updating. It's going to go on forever. There's going to be hundreds of events, and not too long from now, and that's expected. The continuous optimization that's going on there. The other thing, though, that's actually worth showing here is now I'm going to go into a little bit more dramatic example, right? So for this example here, so what's happening? Okay. I don't know what the best way to do this is. Okay, I'm not going to show my video here, but what I'm going to do is I'm just going to cut so I'm on edge number 2, right? So what I'm going to do here for edge number 2 is I'm actually going to kill the node, right? So I'm going to force a shutdown. And then what the system's going to do, okay, so my edge is now unreachable, right? So system has noticed that, and we don't have the SON attached on the second one, right, as we said before. But now what we have is we've actually healed the service, right? So healing in this case was pretty simple, right? All we're doing is changing our load balancer, mapping our DNS, and then eventually, we're hoping that ACM will be able to restore that node. We, of course, don't know if it's been, whether it's going to be coming back or not. Eventually that will, in this case, it should reboot it in a little while, and then we'll be back in business. But already in that sort of split second, we were able to detect the drop and then, leverage all the good stuff that we have behind us with the management. So that's the end-to-end demo. I know it was pretty quick, but I appreciate you guys watching, and I'll sort of turn it back for questions now. Thank you.
So we're here. If there's any other questions, I know there were some questions that came up, I think, during the registration time. Should I just go through those?
Yeah, should we do that? Because not everyone will have seen those, obviously, Dave. So if you're comfortable with just running through that, that's great. Because the other thing is that in the chat, the people can ask questions, but they don't come up in the recording either. So yeah, let's do those ones that came in on the when people registered. There were a couple of interesting questions.
Okay, great. So I'm sure we're just going to work through them in any order here. So there was one question here, and excuse me, I'm going to have to read it and then we'll respond to it. But I think we sort of addressed it, but please address the following edge equipment scenarios: reliability of the equipment, failover, which we sort of just did. What capability exists to handle extreme weather events? This is great. These questions anticipated what we had planned for the demo today. Useful applications included to counter directed energy beams, etc. So I don't know if we did anything for the last question that the person had, but we did essentially respond more generally to the notion of like, hey, edge nodes are going to go out, right? You're going to have thousands, maybe tens of thousands of edge nodes, and there's no way you're going to get roll trucks to all these and get them to be repaired, same within minutes or within even hours per se. That could potentially take days, especially if you have weather event across a large geographic area. So the idea that the system can heal and rebalance across other available or existing nodes for disaster recovery, I think is indicative of the capability here. So hopefully that has been addressed. And if that person's on the call, of course, feel free to send a follow-up question in the text in the chat box. So what are the new MEC use cases emerging? What is the scope of MLA-based MEC applications, network requirements for MEC? All right, these are, again, great questions. All right, so one of the most exciting things we're doing right now with our partner KX is we've actually already done, as far as AI ML is concerned, we already have an industrial, a telco grade, no code, fully declarative, generative AI demo. So this demo, we can do directly in natural language, and we can actually speak to the machine. And the system, and essentially, of course, that's now in a natural language kind of speech. It allows for a designer to be speaking a much higher level way with a lot more flexibility. And the system is going to interpret that because essentially the core of EnterpriseWeb being this highly dynamic orchestration middleware organizes itself declaratively anyway. So now essentially we're taking that API first interface we'd already demonstrated to you, and we're actually exposing it effectively to, in this case it's Jarvis, which is on Microsoft NLP project, and with OpenAI as the foundational model. But very exciting stuff, right? And most of the generative AI demos are really just, they're mostly just about creating first drafts or something that a first-year developer might do. A 50% code complete. They're still doing imperative coding. What we're talking about is completely different. We're talking about EnterpriseWeb's graph providing the context and constraints to enable telco-grade automation. This will usher in a new era of transformative telco solutions. So we're expanding our ecosystem, expanding the use cases. So that's clearly an exciting one as regards to ML and AI. The scope is not constrained by EnterpriseWeb, though. Of course, it's from the telco perspective or customer perspective, because what we're really enabling with EnterpriseWeb is a catalog-driven, telecom, right? And isn't that the vision of Telco Cloud? Is Telco Cloud should be abstracting, all the telco domains, and core transport should be abstracting, all the layers of the protocol stack, such that a customer can maintain a catalog of vendor products, open source capabilities that it can flexibly compose for its use cases based on its strategies, and set its policies for disaster recovery, intent, etc. So the EnterpriseWeb is really all about enablement, and hopefully that comes through in this demonstration. So moving on to that last question is, what is your view on specific business value adds for MEC versus conducting similar use cases in the cloud? Actually, so we started doing that here too, because now this one is a telco. So is there any real-world MEC technically successful deployments other than Netflix Open Connect? EnterpriseWeb is deployed in production. Yes, I can't go into details of things that we've done with customers, but we did 3 states over the last year working with sort of this all-star team of, and most of these players either the number 1, 2, or 3 player in their category. And now with Amazon in the cloud, so an all-star cast, we're actually composing these services originally for private MEC inside the Intel lab, now for public MEC, pushing out the core out to the to AWS's cloud. We're trying to show as much of a real-world scenario as we can in a public demonstration, in a consortium-based project, and I hope that was clear. The future is still to be written for Telco Cloud and for the rollouts of MEC and public MEC. EnterpriseWeb is here to serve those use cases along with all our partners.
So Dave, just a question from me, if I can. So you talked about the testbed earlier on. You talked about showing your partners here again. Is there an actual end game for this particular phase, or is this an ongoing thing that will continue over time with all these guys?
So actually, all of these partners are interested in commercialization. So the nature of the way this is deployed is, again, EnterpriseWeb is 50 megabytes. We can clone this entire environment for any interested telco. There's any interested, so that's a great question. Thank you for that. So for any interested telco, we could easily set up a trial for them. We could take this entire environment, clone it in like minutes, 15, 20 minutes maybe, clone this entire environment to new instances. And then we can actually reconfigure it, recompose it for that telco's specific interests so that they can test it, their scenarios as they see fit. So all of the partners are interested in this. Certainly EnterpriseWeb is interested in it. So, everyone is keen. All the partners are keen for commercialization. So, we have conversations going with telcos already, and we invite any IWPC attendees here to take advantage of that. We'd certainly be willing with them.
Great. Okay. Hey, thanks, Dave. Well, listen, time's just about up. So if anybody has any last burning questions, please either raise your hand and we'll unmute you, or put your question in the chat box. If not, then Dave put Bill and his email addresses up earlier on during the call in the chat box. So feel free to reach out afterwards and strike up a conversation. Dave, you have the list of people that had registered on the call, so you have the ability, obviously, to reach out and make sure that any of those questions that people have, you can continue with them.
Yep.
So, okay. So, any last comments, Dave, before we wrap up?
No, actually, I just want to say thank you, to you, Graham, and to Tom, and the rest of the IWPC team, and we appreciate, being a member of your organization, and we look forward to the Verizon workshop in Boston. That's not too far from us. We're Northeasterners ourselves, so we'll look forward to meeting with you in person. So many of you in person.